Good morning, good afternoon, or good evening, depending on where you're joining us from. Welcome back to another episode of SAP Hands-on Devs. We want to jump right in and pretty much pick up where we left off last week. We were in the middle of really discussing the service enablement capabilities of the cloud application programming model. And in last week's episode, we were looking at how we can customize the service endpoints in our definition of our service, and more specifically, how we can use exit handlers to enhance or override the standard processing. We want to take that concept really a step further today and see how we can impact the entire bootstrapping process of the cloud application programming model service layer. And in doing so, we'll be able to introduce very easily support for OData V2, as well as the default support for OData V4. And even at the end, we'll show you a little trick that you can play around with some experimental support for pure RESTful endpoints using the same sort of concepts. This is also going to set us up for other future episodes, because as we take over the bootstrapping of the cloud application programming model, it's going to allow us to instantiate Express ourselves if we want, to change the default configuration of Express, to inject our own custom middlewares if we want, and to add our own endpoint handlers to Express, or our own routes. So we can have a whole set of logic that's part of our service that isn't actually implemented in the cloud application programming model, nor does it need to be modeled in CDS. We can write the logic from scratch ourselves as custom RESTful endpoints, or other types of interfacing. And we're not going to get into the details of how to do that today. We'll leave that for next week's episode, but everything we're going to do is really going to set up our ability to do that. In the past, in projects where I've had cloud application programming model and did examples where I had custom endpoints as well, really had to create a completely custom service entry point and take over all the processing and then manually bootstrap CDS inside of that. What we're going to see here is how we can take our custom logic and really bring it to the CDS model so that it still works even when we're doing a CDS serve command or a CDS watch. There's a great improvement that came recently with the Cloud Application Programming Model version 4. It was just released just a little over a month ago. So that's the approach that we're going to use in today's episode.
So what we want to do now is basically we want to take over or enhance the whole bootstrapping process so that when the CDS runtime starts up and starts serving our service, we can influence everything about that startup process as well, even to the point where we can get access to the underlying Express instance and add our own non-cloud application programming model handlers to the service endpoint. This is going to let us do several things. This is going to let us easily integrate in the OData V2 Proxy so that we can generate an OData V2 endpoint for our services as well. But it's also going to let us write our own custom REST handlers that haven't been modeled in the cloud application programming model. And this has some advantage to be able to break out, reuse existing non-cloud application programming model items, use third-party modules to help you process your logic. Maybe you'll build REST endpoints that don't require you to model the whole payload in the CDS syntax. So there's lots of reasons why you might want to mix and have the capability to do both cloud application programming model and your own service endpoints. But what we're going to want here is a little bit more auto-magical file naming. And this one we want to put in the root of our SRV file, our SRV folder, and we're just going to name it server.js. And this one, the name is very specific. The CDS runtime is going to look for a file specifically named server.js, and it will use it to enhance the bootstrapping of the whole runtime. So now that we've added a server.js, let's start real simple here. Let's just put a console log message out here to make sure that we're really picking this up. Okay? We'll save that. And now let's just do a cds serve from the root. And what did I get? Custom bootstrap. Yep. So cds custom bootstrap from srv server.js. So it did trigger my console log, but we don't have enough logic in the server.js yet for it to serve as an exit to the bootstrapping process. That's why we got this internal error, server.js is not a function. It's basically saying, oh, you don't have enough logic in here, so I'm going to drop out. But I wanted to do this just to show you that, yes, it is picking up this file. It is using it for bootstrapping. We see that because we haven't gone any further in our processing yet. But we need to add a little bit more logic here to our server.js before it can effectively start the cloud application programming model. So I'm going to pause so I can do some typing, and then we'll come back in just a second, and I'll explain to you what all the logic we're going to put in here and what it's going to do. All right, and what we see here, just coming back to our custom bootstrap server.js, is that all we have to do to make this really work is export cds server. So the CDS runtime provides a server implementation, the initialization of Express and everything. If we want to use the pure standard CDS server, just like we've been getting with the cds serve command, all we have to do is export that out. And if I were to run this now, cds serve, what you see is it does start up. We see our custom bootstrap happens before any of the processing of the inner files. And we see that our service is listening on port 4004 because that's the standard CDS server startup process. But what this bootstrapping allows us to do, and this is going to be really important to the rest of this project, is if we take this out, if we take out the standard, didn't want to completely get rid of that. If we take out the standard and we put in our own implementation. So what we're doing here is now we're exporting the results of a function, which ultimately will be an HTTP server, which is what this exports as well. But what we're doing inside here is we're going to take responsibility for starting Express ourselves, where we can set our own port. So instead of the default 4004, we're going to override that to our own port of 4000. Mostly I'm just doing that to show that we're overriding the standard processing. But this is going to allow us to do our own bootstrapping of Express. Now, we haven't actually added this yet. What we're going to do is we're going to delegate the Express startup and configuration to another file in a folder called server express.js. Doesn't exist yet. We haven't created it. So we're going to put a little logic in here to basically say, check to see if that exists. If it doesn't, then skip it and go ahead and do a CDS server and initialize it. But if it does exist, then process it. So we're getting our own implementation of Express. The CDS serve is going into it, and it lets us tack on additional logic, what we can use to add our own custom Express handlers or change the configuration of Express to add custom middleware, which might not be injected by the standard cloud application programming model startup. So this is a really powerful concept of giving us more control than what we would get with just a standard CDS serve. So let's go ahead. Yeah, I did save that. Let's now run this again, cds.server. And what we see here is that, yes, we still get our custom bootstrap. All the rest of the processing is the same. We didn't have to code the entire bootstrapping process. Most of it is still done by the standard framework. But now we see that we're running on port 4000. And if we open that, it still works. Everything about this, it still works. But now we have more control over the express HTTP server that is running behind that cds.server command. We have the ability to influence it, as we'll do. Well, we're running a little short in today's video, so we'll probably take us up to the point of getting all this initialized, which we've about done, and we'll come back next week and we'll see how we can inject our own custom handlers, our own server configuration. There's a lot that we want to do there, so it's more than we can cover in the time that we have allotted. But the last thing that I want to show you is how, using this custom bootstrapping, we can also add in other handlers, as we've said, but specifically the OData V2 Proxy handler. So next, we want to add support for OData V2 as well, and we're going to use the same server.js bootstrapping approach to add the V2 adapter proxy in here. If we look at the help documentation for Cloud Application Programming Model, we see that although Cloud Application Programming Model defaults to OData version 4, we now have official support for OData V2 via this proxy module that will run between your endpoint and your main service, and it will adapt all the calls to be OData V2. It's relatively easy to add to our project. We need to add the additional module, SAP CDS OData V2 adapter proxy, and then in the same server.js where we're bootstrapping, we can use the special CDS on bootstrap event, and we add additional logic into that event handler. So we'll get all of our standard, or in our case, our slightly adjusted bootstrapping, and then we can add additional logic in there as well. Now, the only thing is that the proxy by default is designed to run your V4 services just with no path, and then to run your V2 services with /V2. I wanted to get a little fancier and have a custom path for my OData V4 services, and then have an additional custom path for my OData V2 as well, which is easy to do because there's configuration parameters that we can pass into this OData V2 adapter proxy as well. So let's come over here and let's see what we've done. First of all, I have added that additional module in the root package JSON to the dependencies at SAP CDS OData V2 adapter proxy. And then I did a npm install so that we get the files for that module pulled in. That's pretty standard, nothing too fancy going on there. But in order to configure this, we added another section to our CDS configuration in the package JSON, this COV2AP. And you might wonder, well, how in the world did I know to do that? Well, pretty simple. If I go to npm.js and I search for this module, and I'll get the nice README document. And if I scroll down into the README document, it has all the options that can be passed in. And we can do this in code when we bootstrap it, but it also says that we can configure all these proxy settings via the configuration section, CDS COV2AP, and then they'll be pulled in automatically. I like that. It gets our configuration out of our code and into one central location. But this is also how I knew which parameters to use to set the different paths that I'm going to use here. So going back to our code, what I've done is I said target path, which means our target service that we want to proxy. Well, I know that I've set all those up to basically run OData/V4. If you remember back, let's just go back to our service.cds. That's what we configured here, a path, OData V4, and then I gave it a name, which happened to be the same as the service name, but I could have given it a completely different name as well. I could override the service name as well as the path. But done the same here with OData V4, master data service. So what I want to do is tell this OData V2 proxy that expect that the target path is going to be OData V4, and then I want to override the V2 path, so it's not just /V2, that it's OData /V2, so that they're nice and consistent. And while I'm in here, disable network log false, so I'll get extra network logging, which I like during development time, just to help me troubleshoot if something's going wrong, and then I can easily flip this on and off with this configuration flag. Now in the code of the server.js, there's very little that had to be added here. I had to add a reference to the require statement for the OData V2 proxy, and then the additional event handler, CDS on Bootstrap, and app is express, so it's going to pass in our instance, our express instance there, and we're basically saying use this proxy. And the functionality in the proxy is going to do all the rest for us. You know, it's going to go look up the environment and get the configuration that got loaded via the package JSON. It's going to initialize this V2 proxy, and it's going to know where to point over what service endpoints in our base configuration of our CDS model. So without adding anything else here to any of the other processing, you know, and in fact, if we were using just standard CDS server and we weren't wanting to monkey around with our own custom express endpoints and configuration, I could just have module.exports CDS server in here, and I could have CDS on Bootstrap add proxy. If that's all I wanted to do was add the proxy, I would really only need this section of the code. I wouldn't need any of this additional processing. So it's very easy to add the CDS OData V2 adapter now to your existing project. Let's go ahead and run this. Let's just do a CDS serve. We'll give it a second to start up, but let's roll back, and what we see is, yes, we're using our custom bootstrapping, and here we see the proxy being created. It is listing on port 4004. We see our proxy rewrite rules that says anything that's OData V2 will be rewritten to OData V4. That comes from our configuration, and then it loaded our models from our base just as we would expect. We see our two original service OData V4 being served out. Okay, just what we expect. Let's go ahead and open that in another tab. There we see our OData V4. They still work exactly as they did before. There's our business partners. But now let's just change the URL. Instead of OData V4 master data business partners, let's change this to OData V2 master data business partners. And there we go. There's our OData V2 document. Not wildly different, but you might notice some little structural changes here that are different in between OData V2 and OData V4. Probably the place where we can see the most drastic changes is if I would look at the metadata document. And let's change the OData V4 metadata document where we see the version right here at the beginning. Let's change this to the OData V2 path. And now what we're getting, should get, well, I have a little browser plugin here that should format my my OData XML documents, and it looks like it's doing some wacky things here. Why? Seems to be calling that correctly. I'm not exactly sure. It's redirecting to OData V2 master data service. Response 200. Yeah, seems to be working right. Is it just my little plug-in here? 1 second. All right, so I ran into a slight complication. Nothing we can't solve, though. Mainly because I'm wanting to get really fancy here and use custom paths for all my services and then proxy those with custom paths as well. This is good. This lets us explore and see what we can do and how we can tinker to get this kind of thing to work. And what I found out is using the target path and path to switch things around works pretty well for the actual service calls, but when it came time to call the metadata service, it seemed to not apply that quite right. It was still looking in the service document for a request path that it was saying service definition not found for request path of just / master data service in this case. So because in our service CDS, we put a custom path in here, it couldn't match that up to the then unproxied path that was being calculated. And I don't know exactly why that is different for the metadata document as opposed to the data calls themselves, where we're using this configuration to change the target path works fine, but then it doesn't for master data. But that's okay. We can fix this. I was actually playing around with something else here, putting my configuration in line there. But let's change this back. We'll still use the target path and path OData V4, OData V2, but this is an interesting opportunity to see how we can actually add additional service endpoints for the same service definition. So just like here, we said we declared this master data service, and here was the path, and here was the handlers. In our Bootstrap code, we can add more endpoints. So what I've done here is I've added just a V2 fallback handler that will be the V4 handler that's defined in the in our service CDS, as I'm saying from telling it to pull from there, but I'm telling it specifically which service to serve, the PO service in this case, the PO service. But then I'm telling it at /PO service or /master data service. So I'm taking the path back off the beginning. And what this will do when I run this, let's just go ahead and run this real quick. Do a cds serve. And what we see here is, yes, we're still getting our proxying OData V2 to OData V4, the rewrite rules there. But in the startup, we actually see we're serving master data service at OData V4 master data service, PO service at OData V4 PO service. But then we actually see another set serving master data service at /master data service and serving PO service at /PO service. So what we see here is we've added a second endpoint to that same service definition. And now when we come over to the test tool, we can actually see it here that we've got OData V4, master data service, there's the metadata document for it. But we have another one here, master data service. And we can see the, if we add the $sign metadata to it, we get it at this URL as well. All right, so what that allows us to do now, if I would go back, let's just go back here to my V4 service, let's go to addresses, and just like before, if I change OData V4 to OData V2, yes, the data call works. It is being changed into an OData V2 call. But now, if I want to go back to the OData V4 metadata document, and now if I change that to V2 for the metadata document, it also is getting translated correctly. And it's getting turned into an OData V2 metadata document. And if we were to look back at our calls here, we would see, yes, this is calling OData V4 master data service metadata, but now it finds it, even though we're still at that base URL. When we proxy that URL, it now finds the service definition because we've served that out with just a slash on the front of it. It's able to find that and proxy the metadata. So obviously that OData V2 Proxy is handling data calls differently than metadata calls, and the rewrite rules weren't being applied in the metadata calls, but we were able to work around that by simply adding another custom endpoint here. And if I want to get really fancy now, I can even come along, because OData, not only does Cloud Application Programming Model support OData v4 and OData v2 via the proxy, but there is some experimental support here for pure REST handlers. And just like we were able to add another endpoint here, let's add this REST URL. Let's define this. Just go ahead and define it here. So that we'll take the same services and now we'll do a pure REST endpoint for them as well. Let's go ahead and save that and rerun it. And now what we'll see is it's now serving master data service at /REST master data service, but it's going to be generated as a REST service instead of an OData with Fiori annotations, which is what we generated before. So let's go back to our page. Here we are. And now what we see is we have our v4 master data service. We have our callback endpoints, but we also have our /REST PO service endpoints as well, which he gave me, I found because there's nothing at that level. That's right. So there's no metadata document because these are pure REST endpoints. There's no additional OData specific features, but what I have is a pure RESTful endpoint for our entities now as well. So PO service addresses, or if I come here, /REST master data service. Let's look at the user, for instance. There we are, a pure REST endpoint with no OData specific features, the metadata, additional URL parameters, or anything like that. But if I want a pure RESTful service endpoint, I can generate that out of the same service definition as well. So what we have seen here today is the ability to model our services independent of the actual implementation, as we were able to create OData v4, OData v2, and pure RESTful service implementations of our single service definition. We've also seen how that we can affect the bootstrapping of the service and override or enhance the standard service handlers to add our own custom logic in. In next week's episode, we'll continue with this concept and do the part that we didn't have time to do. It's worth a whole episode of its own to really begin to build out this idea of enhancing the Express server itself, changing its configuration, and adding our own custom handlers, not CDS event handlers or Cloud Application Programming Model event handlers, but our own custom handlers that we're going to attach to Express directly, and bypassing the Cloud Application Programming Model processing completely, but hanging that within the same service endpoint as our Cloud Application Programming Model.